Lesson 2-4, solving systems of equations algebraically. This is on page 99. Solving systems of equations algebraically, page 99. Notice this is after lesson 2-3, which was solving systems of equations graphically. You guys remember graphically, suppose you have two linear equations. If there's one point where they cross, that could be the solution. You could express as a coordinate, x comma y. Or if they ended up being the same equation lying on top of each other, there were infinitely many solutions. Or if they were two parallel lines, then they would never cross, so there would be no solutions. So this is the algebraic version of the same idea. Like if you turn each of these into graphs, then the solution would be wherever they cross, something like that. Yeah, but here the main methods are going to be substitution and later on elimination. So substitution and elimination. And next semester, we might even do matrices, which is a different way to do it too. All right, so let's look at first example here. Substitution when there was one solution. And right after that, we got, all right, so this is example one. They give us 8x, it's great here, minus 3y equals -1. And then x plus 2y equals -12. Okay, so what I can do, this is my system, right? System. Okay. Again, I could turn these into graphs and see where the graphs cross and find the coordinate, and that would be the answer, right? It would tell me exactly what x and y are, right, in terms of like a coordinate. Okay? What I can do here is I can solve for one of these variables in terms of the other. What is x in terms of y? And I can pick either one of these equations to do that, and then substitute that value into the other one. Now, what I see right away is probably the easiest way to do this is to solve for this x right here in terms of this y, because it has no coefficients. I don't have to divide anything after the fact. So I'll have no wacky looking fractions, anything like that. I can substitute that into this x right here. So let's try to see if I bring this guy down here. Could I just do this? Could I subtract off the 2y and say x therefore equals negative 2y minus 12? See how I just subtracted 2y over, right? And so I have this type of expression right here, okay? And then I can substitute that into that x right there. Right, so bring this down. So 8 times, but instead of x, I'm going to say x. I'm going to say this whole expression right here, because this is x now. Negative 2y minus 12. Right? And then how does this finish off? Minus 3y equals -1. Okay? Okay, so I can continue down here. Now I have one equation with one variable. I can solve for y. And I can come, after I get y, I can come back to this expression I dash outline and get what is x. And that should be the answer. So let's see, I'm going to distribute. So this is negative 16y minus 96, then minus another 3y equals -1. You know what? I have four terms and they're all negative. It's okay if I just multiply everything by -1. Just like that. Okay, so that looks a little nicer. So you bring the y's together. That's what, 19y? 19y. Okay. And then I can subtract over the 96. That would be -95, wouldn't it? Because 1 minus 96. Oh, you know what? Yeah, 95 is a multiple of 19. Because 95, 19, it's like 5, and it's also negative. So y equals -5. Okay, that's part of the answer. Right, so I know y is -5. Okay, so it's an integer. That's really nice. Now I can take that and substitute that into that y right there. Bring this down. So x equals -2y, but instead of y, I'm going to substitute this -5 right here. And then minus 12, right? So I'm just copy pasting this. And then, of course, substitute in the y value. Negative 2 times -5 is positive 10. 10 minus 12. Here, I'll spell that out. Got 10 minus 12. It looks like -2. So that's my x value is -2. Okay. So, so the solution then, in terms of like a coordinate, would be -2 comma -5. Right. That's my xy coordinate, isn't it? Right. I could also substitute. Well, okay, yeah. Here, let's see if this actually is true for both statements. So when x is -2, y is -5. Okay, so if x is -2, that would make this -16. I'll drop that down, maybe pinking up here. -16, and then -3y So that would be plus 15, wouldn't it? Because negative, negative makes it positive. Okay. Well, that would be -1. Oh, and that is -1. Yeah, check. Bing, works. Does it work for the second equation? I mean, it should. Okay. So x, and we got -2 for x. So I'll go up here and say -2, and then plus 2 times y, and for y we said it's -5. So 2 times that would be -10, wouldn't it? Okay. So -2, -10, that does give me -12, and it should have been bing, -12. Oh yeah, checks out. That's how it all works. All right. We are off to a good start. Right. Now example two, they do what was this? When there is not exactly one solution. I think there's some kind of trick they're bringing up here. There's some kind of trick going on. I wonder what is the trick going to be? Well, let's find out. Okay, copy down what they have. So they got -5x. So let's see, example two. Okay. -5x plus 2.5y. Well, yeah, probably that. I'm already thinking, I wonder if I should turn that into a fraction as 5 halves, but here, let's get down first. Equals -15. And then y equals 2x minus 11. Uh, okay. Now, what I already, oh yeah, you know what? Okay, my next slide, see this already written out. It says the equation two is already solved for y. So you could just substitute it straight into the first equation for y. Yeah, we don't have to do any rearranging, nothing like that. Okay. I can just take this already handed to us value of y right here. And so, whoa, where'd my y go? Oops, sorry, this is a y right here. Oops, there we go. Sorry, 2.5y. Okay. There we go. Just substitute that here into this y right here. Okay, so let's do that. Here's my system of equations. Okay, but bring this one down. -5x plus 2.5, and then instead of y, I'm writing 2x minus 11 because that's also equal to y. Equals -15. Okay, so now what's going to happen? You know what? I do want to make this a fraction. Let's do -5x plus maybe this 2.5. It's not like 5 halves. And then 2x minus 11 equals -15. Okay. Now there's different ways to finish this off, but I'd like to get rid of that fraction maybe. So can I take, I basically have three terms here, right? Point, point, point. I can multiply the whole thing by 2. So 2 distributes into each of those three terms. Just get rid of that fraction. Right? Not the only way to do this, but it's one way. So -10x plus 5, and then 2x minus 11 equals -30. I think that checks out. Right? Right, so I have to distribute this 5, so -10x plus 10x minus 55 equals -30. And here you probably see the conundrum, because ruh-roh, what is this right here? 0, and then I'm getting -55 equals -30? So of course, that's a false statement. It's a false statement. Okay. And what does that mean? How do you interpret that? And the way you interpret this is it means, therefore, there is no solution. That's really the answer. There's no solution. Okay. Now, last lesson, I remember that if you have two linear equations and there's no solution, that graphically they showed up as parallel lines. You know what? I'm going to throw these into Desmos real fast. Okay. See what these equations look like in Desmos. I bet they're parallel lines. Got them in Desmos, and okay, boom, boom, exactly from. But oh yeah, yeah, look, that is parallel lines right there. Yeah, there you go. So they never cross, so there's no solution. Okay, and if you were using the substitution method, then you would see a false statement like that, and that's how you would know. All right, so yeah, there you go. All right. Oh, apply the substitution method. Now, I really like this word question here. We got Miss Washington preparing a hydrochloric acid solution. She will need 300 milliliters of a 5% HCl solution for her class during the lab. She has a 3.5% solution and a 7% solution. So the 3.5%, that's too dilute. She needs a 5. But the 7%, ooh, well, that's too concentrated. Again, she needs 5. She needs something between the dilute and concentrated. Yeah, I bet she could just sort of mix these together and it would like average out to exactly what she needs. Okay. And one more detail is she needs to quantify exactly 300 milliliters. Right. So the question is, how much of each solution should she use in order to make the solution needed? Yeah, all right, that's exactly where I thought that was going. Okay. All right, so we do need to make a system of equations out of this. So how can you make a system of equations? And then, of course, we'll use, I guess, substitution to solve it because we've just done substitution so far. Okay. So I'm going to talk, so this is example 3. Right, yeah, so 3. I'm going to call uh, X equals the volume of the 3.5% solution. Okay. And I'll call Y the volume of the 7% solution. Okay. Okay. Here, and I'll draw you guys out a little picture here. All right, so she's got this one solution that's kind of dilute, and this other solution that's kind of concentrated. Right? Right, she's going to mix these together. Right, so right, until they make the 5% she needs in the middle. And so how can we turn this into an equation? So I know right away if I do x plus y, right, so however much from this one, however much from this one, x plus y, well, it has to come out to 300 milliliters, right? Because her target goal is 300 milliliters, right? That by itself is one of the equations in a larger system. Right? So what's another equation? Well, okay, something with these percentages. So if I do 3.5% x plus 7.0% y, that does have to come out to, that has to average out to 5.0%. So that's the target goal, right? Right. Of how much? Of 300 milliliters. So I'll call it 300. Remember, X and Y are volumes. 300 is the final volume. Okay, so some percent of some volume. Yeah, okay, that checks out. So this is my system right here. System of equations. Now, since this was an example, your book does help you out a bit. And just to point out, I might solve it a little bit differently than they do. Notice they went with like decimal interpretations. So 7% is really 0.07, isn't it? Because it's 7 over 100. You could do that. You could say 7 over 100 here and put each of these over 100. But do you guys sort of see that if you like, it's just the percent cancels out, the over 100 cancels out. So however you want to do it. Okay, so let's see. If I do substitution, I could do this. I could take this top expression up here, solve, say like y in terms of x or vice versa, or bring that down. Could I say like y is equal to negative x plus 300? Okay, see, I just subtracted the x over, boom, like that. And then I can take that expression right there and substitute it into that y right there, because y is this whole expression. Okay, then bring that down. That's going to look like, here, I'll just go and drop the percent. So it's to be 3.5x, because it'll all work out the same, okay, plus 7, okay, times, right, and instead of y, I'm going to say this expression right here, negative x plus 300, or 300 minus x, that's okay too, okay, equals, you know what, I can just multiply this out, is 5 times 3, that's what, 15, and then 0, 0, I think that's right, right? So this bit just became boink, that right there. All right, I think we are looking pretty good so far. And we go ahead and distribute the 7 right here. So it's 3.5x minus 7x plus 7 times 3 is 2100 equals 1500. Okay, doing so far so good. All right, so this right here, 3.5 minus 7 is negative 3.5. So negative 3.5x equals, and then 1500 minus 2100 is negative 600. Right. Right, so I got two negatives, so the negatives will cancel, but it's 600 divided by 3.5. I'm getting x equals 171.4. Okay, and then the decimal goes on. I'll just round right there. And the unit was milliliters, right? Wait, no, was it milliliters? Yeah. Milliliters. There you go. Milliliters. And so that was all right, this is the volume. There you go. Okay. Now that's one of the answers. Okay. Now, what about how much y equals? Now here's where Well, I got a couple options. The fast way is just to use this substitution right here. Right? Just substitute 171 to that x right there, immediately get y. So you have to add up to 300. And then finally, I will go back and I will check my answer with the other equation that also has to be true. So let's try that. So I know from here, y equals negative x plus 300, and x is 171. So 171.4, whatever, okay, plus 300. These are all in milliliters. So if I take the negative of the answer plus 300, I'm getting y equals 128.6. That rounds to milliliters. All right, there you go. I got my x value and my y value. Like where, remember, back to the beginning, the x was the 3.5% solution, the y was the these volumes here, so the volume of 7% solution. So there's my answer right there. Yeah. And last check, does this work in the original equation or the other? I have the percentages. Okay, so I said 3.5 percent x. Well, here, let's do x plus 7% and then y equals 5% of 300. Right, so I'm going to substitute my answers and see does this really work. Right, so in place of x, I'll put in 171.4. Y, I'll put in 128.6. Now these are rounded a tiny bit. So this might not, I might miss it by like a tiny fraction of a decimal, but we'll see. Okay, what is 5 times 300? Right, that is 1500. Okay, so let's see if these add up to 1500. We're going to say it's 3.5 times 171.4 plus 7 times 128.6. Oh yeah. Oh yeah. 1500.1. Yep. So just like I was predicting, I might be off by like a fraction of a all right, a little decimal, like 0.1. Yeah. So this is good. We're good. All right, so the answer is 171 milliliters and 128 milliliters. All right. Next, elimination. All right, so this is a different method. Different method. So system of equations. And what you want to do here is you're allowed to add or subtract an entire equation from another equation. You can do that. Okay. And what you might do effectively is eliminate one of the variables doing so, hence the term elimination. So example 4, okay, here, I've got my book off screen, I'll just copy down. Negative 2x minus 9y equals negative 25, and negative 4x minus 9y equals negative 20. Whoa, negatives flying all over the place here. That's unnecessary. So here's your system. Okay, show you guys I did copy that straight out of the book. Okay, so this is page 101. Looking at these right here. Boom, boom. Got that. Now, you're allowed to add subtract equations from each other. I might do this. Guys, could I take the entire second equation and multiply it by -1? And if I do that, these three negatives cancel. I have three terms. I multiply each term by -1. That just very simply makes me positive. And now, I can add the two equations to each other. So negative 2x and 4x leaves me with positive 2x, right? 4 minus 2 is 2. These cancel out. Zip, goodbye. And over here, 23 minus 25 is -2. Okay? I can solve for x now. Just divide both sides by 2. Therefore, x equals -1. Right? Okay, now that's my x value. Now my y. Now to finish this off, it's common to go ahead and finish it with substitution. So I could substitute either way. How about this equation here? 4 times, instead of x, I'll say -1. That's it. Right. Plus 9y, we're solving for y now, equals positive 23. Right, see that? Right, so let's see, this is -4. So I can add 4 to both sides, add 4. So I'm getting 9y equals 27. Oh, 27 is a multiple of 9. It's 3. Y is 3. Okay. Okay, so here's my answer right here. So as a coordinate, it'd be like -1, comma 3. Okay. Oh, you know what I should do? I should pull this up on Desmos too and show you guys. Okay. So there's a few ways I can check my answer. I'm going to pop this into Desmos real fast and show you guys that it should cross at the coordinate -1, comma 3. Okay, got them in Desmos. Boing. Okay, there's the two equations. and they, oh yeah, they did cross it. -1, comma, +3. Right. Actually, the second equation I did negate everything, make positive. So if I type it exactly like the book typed it, I bet it still crosses at that exact same coordinate right there. Let's see if it does. If I just slap in some negatives, negative, negative, negative. Oh yeah, it still does. It still does right there. Yeah. All right, so all good. All good. All right, what's next? Got uh all right. Multiply both equations before using elimination, right? Which I kind of did already when I just multiplied everything by -1. But what if the coefficients were completely different from each other? It's kind of what we're getting at here. So what's their example? Copy their example. All right, so we got example 5. We got 2x plus 5y equals 1, and 3x minus 4y equals -10. All right, there's my original system. Okay, so good. All right, so now what? But yeah, see, none of these coefficients match. The 2 and the 3, the 4 and the 5. Right. Now, I can make these look like each other. I could either eliminate the x first or the y first. You know what? Since the y's are opposite signs, maybe I'll just hone in on those. I'd like to add these together and but to do that, here's what I do. I'm going to multiply this entire top equation by 4. So 4 times this entire top equation. And multiply the entire bottom one by 5. So 5 times this entire bottom equation. So multiply, multiply. Okay. And this is going to distribute, 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 distribute. So like both sides of the equation, the whole thing will be balanced. You guys see why I did that? Because I will have 20y here and -20y right here. So I'm setting it up so that they will eliminate. And then I can go finish this off. So how does this work out? I got 8x right here plus 20y, and then that's equal to 4. And then down here I got 15x minus 20y. Ooh. And then equals, that's -50, isn't it? Okay. So this is really the same system. I'll say same system. Or I have like the same solution. Right, get sample. Right. All right, so all right, let's go ahead and add these together. Boom. Uh, ooh, okay, this is a funny looking number, 23x. Okay, I think that's right, right? Okay, these just cancel out. So, and then that's equal to, says -46. Oh, yeah, 46 is a multiple of 23. Oh, yeah. Oh, yeah. It's a good sign. 23, 23. So then x, therefore, is -2. Right? And then let's substitute that back in. So it is 2 times -2 plus 5y, because we're solving for y now, equals 1. Right, so choose -4. So if I add 4 to both sides, plus 4 plus 4, 5y equals 5. Therefore, y is equal to 1. So my coordinate, or well, the answer expressed as a coordinate would be -2, comma 1. If these were graphs, they would cross at that coordinate. Okay. I'm going to check my answer a different way this time. What if I instead plug this coordinate into the bottom equation? I should end up with -10. Let's see if I do. So 3 times -2, that's -6. Drop that down. Minus 4 times 1, which is 4. Right? Is that equal to -10? Yeah, it sure is. -10 equals -10. Check. So it works out. Yeah, so it's definitely the answer. All clear. Right? And last example is they say, what if you're using elimination and it says there's not exactly one solution? I remember how that worked with substitution is there was no solution. So, and remember that ended up with a false statement. So we were going through substitution. We got definitely a false statement. Like, all right. And that meant no solution or parallel lines in terms of graphs. So I'm going to suspect that's where they're going with this. Yeah. All right. So the other example, got it. 18x plus 21y equals 14. Right? And then 6x plus 7, 6x plus 7y is 2. So right now, 6x plus 7y equals 2. All right, system. Right. In fact, yeah, I can tell right away this isn't going to work. Right, guys, here's how you can tell just by looking at the paper. You see how 6 times 3 is 18 and 7 times 3 is 21? Okay, okay, so if you don't know what they're equal to, you know that they're either parallel lines or they're the same line. And then you say what they're equal to. 2 times 3 is 6, which is not 14. Yeah, so they'll be parallel. There's definitely going to be no solution. Right? Let's say I didn't recognize that, right? And I'm just going through the process. What I might want to do is multiply this bottom one by -3. Say times -3, or well, -3 times, or whatever, this whole thing. Okay. Let's bring sound sort of rewrite the system. Boing, boing. Okay. So the top equation will leave as it is. 18x plus 21y is 14. Okay. This bottom one, if I do -3 and I distribute that into all three parts, both sides of the equation, the whole thing, I get -18x, I get -21y, and then this is -6. Okay? Now, if I add these equations together, because it's like the same system here, I get 0 plus 0 equals 8. Okay, so I just got the expression 0 equals 8. Like, what? Right, that's definitely a false statement. Right? And the interpretation is therefore no solution. Okay? So you get parallel lines like that. All right, let's jump into the puzzles. Okay, so here I picked a handful of basic ones to do, and then I do like some of these word questions. I got bake sale here, model of mathematics. Yeah, so I just did two examples here from each section. And so number 5, all right, I'm on page 103, number 5. Copy this right out of the book. Got 4x minus y equals 6 and 2x minus 1/2 y, or y over 2, okay, equals 4. So here's my system. Okay. And they're prompting you to use substitution specifically. So I'll go ahead and do that. I'll just use substitution. Okay. Well, if I want to do substitution, I have to solve for one of these variables in terms of the other. And what stands out to me as an immediate candidate is this y, because there's -1 on it. But I can very simply get y equals something and then run it forward from there. Okay, so if I rearrange this, okay, I get plus y and subtract the 6, going to get y equals, I get 4x minus 6, right? See, all I did was I did plus y on both sides, and then -6 and -6. Right, so you get it back. Okay, and then this other, you know what? Yeah. Okay, let's just see. I'll just copy and paste the other one. I was looking at that fraction. So should I get rid of the fraction? We got 2x minus 1/2 y equals 4. Okay, so it's the same system. Okay, same system. Okay, but now this top expression, I have y equals this in terms of x. I can substitute this y right here. Okay, so instead of y, I'll put in 4x minus 6. It'd be the same thing. So now I have 2x minus half of, and then instead of y, I'm writing 4x minus 6. Right? And this is all equal to this 4 right here. Boom, just like that. Okay. Distribute this 1/2. I get 2x minus, that would be, oh, that's interesting. What's going on here? 2x, I wonder if this is a no solution. Right. Plus, okay, half of 6 is 3, and it would be positive because negative equals 4. Yeah, you know what? I'm getting the statement 3 equals 4. Okay, so right away I'm thinking this is no solution. Okay, I'm going to throw this into Desmos and make sure that these are parallel lines. They should be parallel lines if that's the case. All right, so type those in, boom, boom. Yeah, okay, yeah. Those are parallel lines. In fact, I should have recognized that from the start because look at those coefficients, right? So like if you do 2 times 2, you get that 4. If you do -1/2 times 2, you get that -1. But if you do 4 times 2, you get 8, which is not 6. So yeah, that was destined to always happen, right? Yeah, here, I'm going to do a different substitution out of the book, one that, well, hopefully this one will lead to a solution. So let me do that. I'm going to add one in here. How about number 2? Let's see what happens with number 2. Okay. All right, come on, answer. Let's see, we're gonna find out if this works. Number two, let's do 2x minus y equals 7. You know what? I think I picked another special one. I sure did, didn't I? Or I don't know. We'll see. 6x minus 3y equals 14. Okay. Okay. Here, just went a little faster. So add y, subtract 7, y equals 2x minus 7. Then now here, 6x minus 3y, but instead of y, here, I'm doing this one a little bit faster. It's the same process I just did before. I'll do 2x minus 7 instead of y equals 14. Okay, so it's the same system, substituted. Okay, so distribute that negative 3, 6x minus 6x. Yeah, that sure is. Plus 21 equals 14. Okay, this is not going to work either. This is also no solution. That's a false statement. No solution. All right. Well, by luck. Yeah. Over 2. All right. Got to pick one that actually works, right? Okay, let's try number 3. All right, so number 2, number 5 both came out to no solution. How about number 3? Come on, number 3. 2x plus y equals 5. 3x minus 3y equals 3. Okay, yeah, this one's gonna give us something. All right. Yeah. All right, so here's my system. Right. Now, right away, I see this y is just hanging out by himself, sort of. Right? All I have to do is subtract over 2x. So I'm going to rewrite this as y equals negative 2x, and that would be plus 5. Right? And then bring this one down and say 3x minus 3y equals 3. Right? So it's my same system. But now I can take this expression for y and substitute it right there. And then continue on. So 3x minus 3, and then I have a negative 2x plus 5. This is all equal to 3. Distribute that negative 3. I'm getting 3x, and then negative negative, I got plus 6x, and then minus 15 equals 3. So this brings together to make 9x, add 15 over, that would be 18, right? Right, so it looks like x is equal to 2, right? And then if I substitute that right here, negative 2 times 2 is negative 4 plus 1 is 5. Or sorry, negative 2 times 2 is negative 4 plus 5 is positive 1. So y equals 1. Okay. So the coordinate, like as a coordinate, would be 2 comma 1, right? That'd be the coordinate where the two graphs cross. Like that. Okay. All right, last check. Does that work up here? So if I plug in 2 for x, that's 2 times 2 is 4. Drop that down. Plus y, which is 1. 4 plus 1 is 5. Yep, that's 5. Check. It works. All right, so we're definitely good. Boom. All right, got one to work. All right, number 7. Big sale. Uh, Cassandra and Alberto are selling pies for a fundraiser. Cassandra sold 3 small pies and 14 large pies for a total of $203. Alberto sold 11 small pies and 11 large pies for $220. Determine the cost of each pie. Here's a set of system of equations, and then solve it. Boom. That's it. Do, 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 do. So number 7, big sale. Okay. I'll have x equals number of small pies and y equals number of large pies. Right? Right, so no. That's not what we're doing. That's not what we're doing. Right, scratch that. We gotta start over. Start over. That's not what I want to do. Right, get that. Right, x should equal the price of small pi. There we go. Right, because we don't know the prices. That's what we gotta determine. Y equals the price or the cost, the price of the cost of large pi. There we go. That's better. Okay, forget all that. Not the number of pies. We know the number of pies. They told us the number of pies. Okay. All right, so with that in mind, let's see. 3 small pies, 14 large pies. So if I do 3 small pies times the price of per small pie plus 14 large pies times the price of large pies. That adds up to $203. There it goes. Number of pies times dollars per pie gives me dollars. Okay. Now that's for Cassandra. Let's make an equation for Alberto. He sold 11 and 11. So 11 times the price of 11 plus 11 times the price of small times 11 times the price of large. Okay. Comes out to $220. There. So that's the system we want right there. That's our first system. Did your textbook prompt? Yeah, they did say using substitution, so I'll just go ahead and do it that way. Whether you use substitution or elimination is really kind of up to you in the real world after you graduate high school, but they're prompting substitution. So if they're going to do that, then maybe how about this? I'll solve for this x right here. So I'll bring this down. I'll say 3x equals negative 14y plus 203. Therefore, x equals negative 14 over 3y plus 203 over 3. Okay. Now that is a really wacky looking expression. That's this should come out to nice numbers in the end, I think. I mean, you can only solve down some number of cents, right? We're going to take that and substitute that into this x right here in terms of y. That'd be x in terms of y. Right, let's bring that whole thing down. Boink. Right. So 11x, but I'm not going to say x. I'm going to say this whole expression right here. Negative 14 over 3y plus 203 on 3. Right? That is what x is now. Right? It's the same thing. Right? Okay, plus 11y equals 220. Right? Okay, so there we go. Okay, this is in terms of Alberto substituted some information from Cassandra. Yeah. All right. I'm going to multiply everything by 3. I swear to have 3 terms. 1, 2, 3. I'm going to multiply everything by 3 to get rid of these fractions. So if I do that, well, okay, it wouldn't. Here, how should I do that? I say so 3 times, and then this whole enchilada. Right, so it goes once into this term, sort of, once into this term, and then once into this term, right? So both sides of the equation, I'll balance this, it'll be all good. Okay. The way that would work is, since I have 2 fractions inside of these brackets added up together, I can take the 3 and distribute it there and just leave this 11 alone. So the 11 times negative 14y plus 203. And then, okay, now the 3 does distribute here, gives me 33y. And it also distributes here, gives me 660. Okay. There's more ways than one to do this. I'm just picking one particular method. So if you do a different way, different paths through the forest to get the same answer. I just like getting rid of that fraction, I suppose. Okay. I still have to distribute this 11. Calculator time. What is 11 times 14? Oops. That's 154 and it's negative. Negative 154y plus 11 times 203, 2233. Okay, that's distributed out there. I got another 33y here equals 660. All right, so put my y's together. Yeah, okay. Negative 154 plus 33 gives me negative 121y. Then I'll subtract over the 2233. 660 minus 2233. So minus 2233 minus 2233 equals negative 1573. Now, since both sides are negative, I can drop the negative. Right? Now I have a back with an expression. If I real close, just divide both sides by 121. 121, 121. All right. Come on, nice number. 1573 over 121. Oh yeah, 13, as in $13, isn't it? Because remember, it was a price. It's a price value. Okay. So I know it's $13 for a large pie. This is the large pie price, cost, whatever you say, okay? $13. Okay. So now I can, well, I could use this to get x, couldn't I? I could do that. Or I could substitute there. Okay, I guess I got some options. Let's try it. Let's try it this way. Right. So I know, I remember from before this. So I'm going to take this 13 and plug it in right there. So try that. So therefore, x equals, okay, all right, here, I'll spell it out to make it really clear what I'm doing. Negative 14 over 3, y, but instead of y, I'm going to say 13, because just found that. Right, and then plus 203 over 3. Okay, so x equals negative 14 over 3 times 13 plus 203 over 3. Again, come on, nice numbers. Oh yeah, 7. That dollars with a unit attached to it. And this is the small pi uh, price. Right? Now, reasonably, what should cost more? A large pi or a small pi? I think a large pi should cost more. I hope y is more than x. Oh yeah, it is. 13 is more than 7. Yeah, so that checks out too. Yeah, I think this is good. I'm getting nice numbers, getting whole numbers for that matter. Good. Next one. Use elimination to solve these equations. So I picked two. Well, hopefully one, at least one of these actually gives me a real solution. Because yeah, we'll see. All right, 10. I hope at least one of them does. Good find out. Number 10, I got 5x plus 2. Get this on screen here. All right, so number 10, 5x plus 2y is 12. And then negative 6x minus 2y equals negative 14. Here's my system. Oh yeah, if I just saw this in the wild, I would use elimination anyway, because it's set up to very conveniently solve it that way. Because watch this. If I just very simply add the equations together, what happens to the y terms? They just immediately go away. Okay, so that gives me, this is negative x right here. Okay, then plus 0 this way equals negative 2. Well, if negative x is negative 2, then x is equal to 2. Okay? And then what is y? Well, we can try right here. Bring this down. 5 times 2 plus 2y equals 12. All right, so 5 times 2 is 10. Subtract 10, subtract 10. So 2y equals 2. Y is equal to 1. Right? So it'd be like the coordinate 2 comma 1, like as an xy coordinate. So if I graph those, they would cross that coordinate. Okay? And here's the last check I want to do. We take the other equation and plug in the solution and make sure it totals to negative 14. It should. So here, I'll do that a peek down here. I've got negative 6 times x, which should be 2, minus 2 times y, which should be 1. Right? So that 2, boink, that 1, boink, that's where that's coming from, equals negative 14. I hope. I'm going to put a little question mark here because that's the test. It's the final test. If this passes, then we're good. It's negative 12 minus 2 equals negative 14. Yeah, that checks. That checks out. Negative 14 equals negative 14. Check. We're all good. All good. So the solution is 2 comma 1. Okay. Now let's do another elimination. Yeah, I wanted to do one where I had to multiply by some factor. So 13 looks like that will provide that opportunity. Number 13. It's straight out of the book here. Getting x minus 3y equals negative 12 and 2x plus y equals 11. And there's my system. Right? Now, unlike the last one, if I just very simply have those equations together, it doesn't immediately eliminate any variable. Right? But I can either multiply the top equation by negative 2 or the bottom equation by positive 3 if I want to eliminate either the x or the y. Right? So how about that second thing I said? I'm going to take the second equation and multiply the whole thing by negative 3. Right? The whole equation. Right? Then I'll bring this down and rewrite the system. So boink, boink, rewrite the system. So I'll leave the top equation as is. X minus 3y equals negative 12. So that didn't change. But down here, if I distribute this negative 3 into all three terms and balance the equation, I get negative 6x. And then, but why did I do negative? I'm being silly. Let's just see that positive, positive, positive. Okay, there we go. Positive 3. That's what I did. Okay, plus 3y. See, I'm setting this up. The whole reason I did is just that right there, because we're about to eliminate the y. Like, yeah, 3 times 11 is 33. There you go. Okay, so it's the same system. Same system. If you graph this and then you graph this, those pairs of graphs would look identical. Be no difference. All right, so let's add them up. Add them up. Add them up. I'm getting 7x right here. The y's go away. And is this 3 minus 2 is 1. 3 minus 1 is 2. 21. Oh, yeah, 21 is multiple of 7. Yeah, so that's nice. So getting x, just divide both sides by 7. X is 3, right? Plug in 3 here. Here, bring this on down. Okay, so 3 minus 3y equals negative 12. Okay. So minus 3, I'm getting negative 3y equals negative 15. Therefore, y is equal to 5. Okay, so 3 comma 5, 3 comma 5. Okay. And finally, I'll check my answer right here. 2 times 3, that'd be 6. Drop that down. Plus y, which is 5, equals 11. Does that equal 11? 11 equals 11. Oh, yeah, check. It works. Yeah, that's totally the answer right there. We good. We good. Oh, yeah. All right, 3 more of you guys here. Number 21, the sum of two numbers is 12. The difference of the same two numbers is negative 4. Find the two numbers. Ah, yeah, we do that. All right, so I can call the numbers x and y. I can call the numbers a and b. I could, well, whatever I want. So let's do x and y. That's pretty traditional, right? Sum of two numbers is 12. So sum of two numbers, x plus y, is 12. The difference of the same two numbers is negative 4. Well, I could do x minus y or y minus x. Here, I'll do x minus y. How about that? Either way, right? One or the other. So that'd give me negative 4. Okay, find the two numbers. That matches those conditions, right? Sum is 12, difference is negative 4. That's the system. Okay? You can use substitution or elimination. Now, this one I do like elimination because watch this. I can just add these together. X and x is 2x. The y's go away. They subtract from each other. And that gives me 8. Divide by 2, both sides. X is equal to 4. Right? And then once you got that, you can go back here. Like if x is 4 and I subtract over 4, wouldn't that give me 8 for y? Right? And does that work for the other one? 4 minus 8 is negative 4. Oh, yeah, it totally checks out. Check. So as a coordinate, it should be 4 comma 8, if you like an xy coordinate. Okay. Right, so is the sum 12? Yep. Is the difference negative 4? Well, that minus that is, yeah, that's it. Okay, number 24, model with mathematics. The Newton City Park has 11 basketball courts, which are all in use. There are 54 people playing basketball. Some are playing one-on-one and some are playing in teams. A one-on-one game requires 2 players, and a team game requires 10 players. Ooh. Write a system of equations that represents the number one-on-one and team games being played and solve the system and interpret your results. All right. Right here. Maybe I'll sort of like draw this out. Okay. So we got 11 chords, right? Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 chords, okay? And some of these have one-on-one games where it's just like maybe play here and play here, so there's 2 players. And some of them have team games where there would be 10, they say 10. Yeah, 10 players. So maybe you have like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, something like that, right? And we put all these dots out. Okay, right. So we got 11 quarts. Okay. And got 11 quarts, right? Just like I drew there. Okay. We got 54 players total. Right? And all 11 quarts are being used. All 54 players are playing. And there are 2 players per one on one game, and there are 10 players, like 5 versus 5, per team game. All right, so how can we turn that into a system of equations and then solve that? And what would that represent? And what I'm thinking is, see, what I don't know is how many of these one-on-ones and how many of these team games are going on. That's sort of my X and my Y right there. So I'll say X is number of one-on-one games, and Y equals the number of team games. Yeah, I can make two equations out of that satisfy these conditions right here. I can do that because I know if I add up all the games, it has to add up to 11 altogether to fill up all 11 ports. They said all 11 ports are being used. Therefore, x plus y equals 11. That's one of my equations right there. Okay? Also, I know there are 54 players. So, say if I do 2 players per game times the number of one-on-one games plus 10 players per game times the number of team games, that would add up to 54 players altogether. Yeah, I think that's my system right there. There's my system. So half the fun is figuring that out. Okay, can you figure out how to take that story and map it onto the system of equations? So it's more it's abstract type math. Okay? All right, and then, okay, the second half is just go ahead and solve the system of equations. So you could use elimination or substitution. If you want to do elimination, what I would do is I would maybe take this top equation. I would either multiply it by -2 to eliminate the x's or times -10 to eliminate the y's, one or the other. Okay? Get one variable, they go back and substitute the other one. Okay? Or if you want to do substitution, I would do something like this. Can you subtract over x? You get y equals -x plus 11. I mean, this is this one, right? It's the same thing. This is this. Okay? And then I can take that and substitute it into the other expression. 2x plus 10y. But I'm not going to say y. I'm going to say this whole expression right here, the -x plus 11, because that is y. Okay? Has to total to 54. Then I can solve for x. I have one equation, one unknown at this point, so then I can solve for x. Guess what I already said there, right? Okay. Take this one and rearrange it, got this. Okay. Substitute that into this y value right here. Right? So this is y, right? Aha. Okay. So now I can solve for x. I gotta distribute that 10. So I'm getting 2x plus, oh, -10x. That's interesting. Plus, that would be 110, wouldn't it? 10 times 11 equals 54. Yeah. So -8x. Here, I'll just go ahead and subtract off 110. I'm at it. Okay, what's 54 minus 110? Okay. Equals -56. Okay, yeah, both sides are negative. Aha! Divide both sides by -8. Yep, I'm getting a whole number of games being played that are one-on-one, which should be 7, wouldn't it? 7. Okay. And since I know that the number of courts being used is 11, and 7 is the number of one-on-one games, 11 minus 7, so y, therefore y equals, actually I have it right here, right? 11 minus 7, 11 minus 7, y equals 4. So there are 4 courts being used for team games. Right, so here's one-on-one games, here's for team games. Okay. So 7 courts and 4 courts. Now, the last check I'll do is I will take these and I'll plug them back into this other expression right here and make sure it does add up to 54 players. Let's see if it does. It goes in PT. So I was claiming, say, 2 times 7 courts here plus 10 players per court times 4 courts. Is this really equal to 54? Because if it is, then I did everything correctly. So it's be 14 plus 40. Is that equal to 54? Plus 14. Yeah, it sure is. 54 equals 54. So check. It all works. So this is definitely the correct answer. Okay. I do one more with you guys. Let's go. Number 26, create. Ooh. Write a system of equations in which one equation should be multiplied by 3 and the other multiplied by 4 in order to solve a system with elimination. Ooh. Then solve your system. Right. So multiply by 3, multiply by 4, they cancel out. So what I'm thinking is maybe the coefficients in front of x and y for each of the equations. Here, I'll start real simple. Let's say sum x plus sum y equals something. And then there's a different equation with some different x plus some different y equals like something. Okay? Um, how about here, let's go really crazy. How about like pi and uh, how about pi? I don't know. It's something bonkers, right? Okay. And if you have to multiply 1 by 3 and 1 by 4, I'm sort of thinking like in terms of like a common denominator, common multiple, common factors and multiples, one thing, right? Maybe in front of the x, I could have one of these as a 3 and one of these as a 4 and make one of them for the word negative or something. Actually, that could solve it right here. That could satisfy all their conditions. Okay. If you want to, you could slap something in front of the y or not. Here, I'll go do that. Let's say, how about how about throwing 8 on here? I don't know, just something crazy. Okay. All right. So if that's my system, okay. So if I multiply the top equation by 4 and the bottom one by 3, that would give me a 12, well, negative 12x here and 12x here. And that would very quickly cancel out. So I'll do 4 times on the top and 3 times the bottom, right? So both sides, right? And okay, distribute. So distribute, and then distribute. Okay. Right, so that gives me negative 12x plus 4y equals 4 pi. And then down here, positive 12x plus 24y. Yeah. Right. Equals, and 3 times 5 is 15. Okay, I threw a pi, just pretty wacky, but right. But now, see now I can add these equations to each other and the x's just go away. I'm getting 28y equals like 19 pi. Right? So I'm saying y is, here, I'll just get a decimal. It's pretty close. But it's 19 pi over 28. Whoops, 28. Right? I'll say equals approximately, right? Right, how about that? 2.132. Something like that, right? And if that's true, then I can substitute that back up here, right? So I'll do a pi minus that number. So pi minus that. Okay. And then divide by negative 3. So I just did it on my calculator, but so skip a few steps off screen. X would say approximately negative 0.337. Okay. So if I were to graph these, actually, I will do that. I will graph these on Desmos. I guarantee that whatever I wrote originally in black ink up here, I will get two straight lines because each of these variables raised to the power 1, so straight line. And they will cross at the coordinate negative 0.337, comma 2.132. Yeah, okay. And so we do that. Jump over to Desmos because once they cross right there, we are gold. All right, here, I'll type this in live here. All right, so we got negative 3x plus y equals here to 3.14159. Okay, that'll be enough there. Right, and this other one's going to go 4x plus 8y equals well, I think I could type this right. 5 times 3.14159. Right. I think that should do it for me. Right. Okay, yeah, okay. I do see those crossing right there. And let me make this a little bigger. Okay. And kind of scoot this over. Because I gave you guys a coordinate right here. Let me shift this paper a little bit. Let's fit on the screen a little better. Right. So I said, okay, negative 0.33733. Yeah, that's totally it. All right. And that is a wrap.